teacher!
Hey guys, this week we are going through 5.6a, finding equations of lines. This is where all the algebra starts coming in and we start getting away from graphing. So it's split into two parts. Today we're only focusing on finding the equation if you're given slope and a point that's not y-intercept. And just remember that we don't have a Desmos activity this week, so you will need paper and pencil, and you're also going to need to be able to take a picture of your work. And don't forget to watch these videos on a faster speed if you like. So we're really good usually with slope y-intercept form. And this lesson, we're also going to be going through how to convert from slope y-intercept form to standard form. You know how to do it from standard form to slope, but not the other way around, and it gets a little bit trickier here. So we're going to go through example 1, determine the equation of a line that passed through 8, 7 and has a slope of -1/4. We're going to practice stating the answer in both slope y-intercept, which is y equals mx plus b, and standard form. Now, I know that there's kind of two versions of standard form. If we don't specify what kind of standard form it is, then you can choose whichever, but I am going to be going through it as if it is ax plus by plus c equals 0. It's usually easier for most people. And then the hard part with that is that when we do convert it, we cannot have any fractions, and our coefficient in front of x needs to be positive. So let's start dissecting this question though. So they gave us a point and they gave us slope. So if I was given slope, I immediately know that my m value is going to be -1/4. And then in slope y-intercept form, that's y equals mx plus b. So I was given slope, so I can check that off. Now they gave me this point, and it's clearly not the y-intercept because 0 is not the value for x. However, these values are actually x and y values. So I would have been able, and that's what we're doing today, sub it in for x and sub it in for y, and then the only variable I would have left is my b value, and that's what we're solving for. So we're going to do just that. We're going to substitute these in. So I'll actually put the x and y's in blue so that maybe it's easier to see. So remember that coordinate pairs are always in alphabetical order, like x, y, z. And then you plug it into y equals mx plus b here. So the 7 is going to go in for y, and then that's equal to the slope of -1/4. And then my x value, I'm going to put in brackets, and that was an 8. And then I'm going to add my plus b on the end because I don't know what that is. That's what I'm solving for. And so here it comes back to remembering how to multiply by fractions. If you remember our fraction dance, all whole numbers have a denominator of 1. And so if 8 times -1/4, I do the straight across for multiplication. Do the straight across for multiplication. So -1 times 8 is -8. And then 4 times 1 is 4. So that is my answer, and I leave plus b. I would recommend you reduce fractions whenever possible because it's much easier to deal with. -8/4 is the same as -2. And see, now I don't have any fractions, so it's much easier to go back in solving equations. I want to isolate for b this time because that's my unknown. So I have to get rid of this -2 by bringing it to the other side. And I do that by doing the opposite. So if it's -2 plus b, it's like saying b minus 2. So the opposite is actually adding 2 to both sides. And I can see that -2 plus 2 is 0. So those go away. And then 7 plus 2 is 9. And so therefore b is equal to 9, and that would be part of it. I'm not actually done though, because the question was state the equation in both slope y-intercept form and standard form. So if I have my b value and I have my m value up here, now I can go and say that my final answer is y equals -1/4x plus 9. And that is actually the final answer. Then I am done figuring out the equation for slope y-intercept form. Now, it was asking though for standard form as well. So I finished my slope y-intercept form, but I got to convert this to standard form, and I'm going to be using ax plus by plus c equals 0. Some of you may choose to use the form ax plus by equals c. I don't actually care which version you use when you're flipping it back to standard form. Some websites actually said that this one is called the general form, but I don't care. You can choose which one. I do think this is easier for most people because everyone just brings everything to the same side, but that's totally up to you. Either one is correct. So if everything has to equal 0, then I have to bring all of these terms to the same side, and x has to be positive. So because this is negative, some people will bring the y over, some people will bring both of these over. Again, it doesn't actually matter. So I'm going to say, if you just want to bring one thing over, you could say 0 equals negative 1 over 4x. And then if the y gets carried to the other side, it becomes negative. So it's minus y, and then the plus 9 stays the same. The only thing that changed was this negative sign here. And then the other issue though is that, oops, sorry, I gotta extend my page. I'm running out of room. Or I probably should have brought this over to the other side actually. Let's do that. So let's bring this over here. So standard form cannot have any fractions. So this goes back to solving equations where I have to clear fractions. Lucky for me, the only fraction here is this negative, it's the 4 on the bottom, which means that my lowest common multiple, if that triggers anything with anyone, sounds familiar. If the LCM is 4, that means that I have to multiply every term by 4 to get rid of it, because 4 divided by 4 is 1, and those will cancel out. So my fraction is gone. So that means that I would be left with 0 equals negative 1x minus 4y plus 36. And so you can see all of my fractions are gone. So I cleared my fraction, so that's good. But my leading coefficient has to be positive, and right now it's negative. So the way you can do that is you actually just switch all of the signs. So this negative is going to be positive 1x, which is just x. This negative 4 is going to be positive 4y, and this negative 36 is going to be negative 36. And then you can leave the equals to 0 on the end of that. And that's how you can convert from y-intercept form, slope y-intercept form, into standard form by clearing the fractions. So that's example 1. I know it seems a little bit more complicated than other ones, but it's because it's all algebra. We're not really dealing with graphing. So again, feel free to slow it down if you need to, pause and replay, but we're going to go through another example. So in example 2, determine the equation for line in the form of this, which is like our general standard form, that has an x-intercept of negative 3 and a slope of 3 over 2. So again, we were given a slope, which is 3 over 2, so that's nice. And if you need to write y equals mx plus b somewhere so that it's like a refresher, that's fine. So I've checked off m, I have my m. An x-intercept of negative 3 is an indication that this is a point on the graph. So they are actually giving you coordinates even though they only gave you one number. And if you remember that all intercepts have a value of 0 somewhere. So if it's an x-intercept of negative 3, that means that my y value is 0. Because if I were to plot it, it would be 1, 2, 3, negative 3 would be here. So that's negative 3, 0. So in essence, they are giving me my x value and they're also giving me my y value. So I can plug those into my slope y-intercept form. So the y value is 0, so I'll plug that in. My m value is 3 over 2, so I can plug that in. And my x value is negative 3, so I'll plug that in. And I don't know my y-intercept, so I'm going to leave that as plus b. And the reason why I was putting it in brackets is because technically if you're substituting numbers in, you're supposed to put brackets in. It's just proper technique. And then I remember how to multiply fractions. All whole numbers have a denominator of 1. And then I do the straight across for multiplication. So I'll keep this as 0. 3 times -3 is -9. 2 times 1 is 2, and it's plus b. I want the b by itself because that's what I'm solving for. And lucky for me, I have a 0 on the other side of that equal sign. So when I add 9/2 to both sides, it luckily just becomes plain old positive 9/2. So b is equal to 9/2. And that's my y-intercept. And so it's helpful to still write it in slope y-intercept form because then you can see how you need to convert it into standard form. So that's my slope y-intercept form. My slope is 3/2. My b is 9/2. And then to convert it to ax plus by plus c, I got to bring everything over to the other side. So it makes sense to bring the y over. So I'm going to have a 0 is equal to 3/2x minus y, because I can subtract y on both sides, minus y. And I'm putting the minus y in the middle because I know that my form has to have x and then y and then the constant. And then I'll recopy what was left, which was the plus 9/2. So I have a positive leading coefficient, but they are in fractions. So I have to get rid of that fraction by looking at my lowest common multiple, which in this case is 2. So if my LCM is 2, I'm going to multiply everything by 2 times 2 times 2 every term. So 0 times 2 is 0, so that can stay there. 3 times 2 divided by 2 will cancel out to just 3x. Negative y times 2 is negative 2y. And then 9 times 2 divided by 2 will cancel out to positive 9. Now, some of you before, you had done 9 times 2 and you said it was, you would say it was 18/2, but 18/2 is the same as 9. So if you would like to write this and then simplify it later, you can do that in 2 steps, but I'm gonna just skip over that. So this is good. I've got a leading coefficient that's positive. All my fractions are gone. I just need to rewrite it so that that 0 is on the end instead. And I'm gonna actually just start doing that from now on. You don't have to keep the 0 there. So this is my final answer for that example. The next one is a word problem. And when we have word problems, we don't usually ask you to make it go into standard form. So you can keep it in slope y-intercept form. Total cost of a charm bracelet is comprised of the cost of simple bracelet plus that of the charms. Each charm costs $16 and a bracelet with 9 of these charms is worth $179. So the first question, what is the independent variable? So we got to look at our units for this. Clearly we have cost as one of them. So it's possible that cost is going to be a variable. And also you should have been able to see that something else that is changing, if you think of like Pandora bracelets and stuff, the other thing that's changing is the number of charms on the bracelet. So now we have to think about what is the independent variable, the one that doesn't depend on anything. And that would have been actually the number of charms. So the number of charms is going to be our representing of the x, or the x-axis, because the x-axis is always the independent variable, and the cost in dollars is our dependent variable. And that makes sense, right? If you're thinking of a graph, the more charms you buy, the higher the cost of the bracelet is going to be. So that kind of makes sense intuitively. So that was the easy part. The harder part is coming up with the equation. So we have to kind of dissect what this is telling us. If each charm costs $16, like $16 per charm, that's telling us what the slope is, because the slope is changing by $16 every time you buy a new charm. So this is going to be my slope. And then if it cost $179 when you bought 9 charms, if I were to plot that, for example, 9, that's telling me a coordinate. That would be 9 charms is $179. So the 9 is my X and the Y is my cost. So that gets a bit tricky. You're just going to have to practice those to analyze what the word problem is telling you. But I can start subbing it into my equation of y equals mx plus b. So again, if you want to write y equals mx plus b, you can do that. But this step is optional. Sorry, my writing's really terrible, as you know. But my y value was 179. My m value was 16. My x value was 9. And I don't know this b value. Oops, I'll put that in green. I don't know that. So that's what I'm trying to figure out. So once I have substituted in all of my values, I can start doing the math. So 179 is going to stay here, and then 16 times 9 is 144. So I've got to write that in, plus b, and then I'm trying to solve for b, so I want b by itself. So I got to bring that 144 over to the other side, and I'm going to subtract 144 to get rid of it. And then 179 minus 144 would be 35. So this cancels out. So my b value is equal to 35. So this, the bracelet without a charm would be $35. So I can write my equation then is going to be y equals 16x plus 35. So that's my general equation. And then the second part to that was use the equation to determine the cost of the bracelet with 5 charms. So 5 charms is giving me my x value. So this is going to be x, so I can plug that into my equation. So y is equal to 16 times 5 plus 35, and that will give me my cost. So 16 times 5 is 80 plus 35, and so let's extend my page out. So y is equal to $105. And then that's my final, oh sorry, 115, my bad. Whoops. 115. 115. So because it's a word problem, I'm going to write therefore the bracelet will cost, oh gosh, my writing's gone so much worse since the school closed. The bracelet, sorry, will cost $115. And that's the word problem. So you can stop watching this video if you want here, if you're good, and try the practice questions on the Google Classroom, or you can continue watching. I'm going to go through 2 more examples. The first one is just rearranging back to standard form, which is clearing the fractions and making the leading coefficient positive. And there's going to be one other example of finding the equation of the line, and then there'll be the what's next slide. Okay, so in this example, we're going to be reviewing coming up with an equation given a graph, and then we'll convert it. So in this graph, determine the equation of the line. We're going to have to do it first in y equals mx plus b form. So they've highlighted that y-intercept for me, which is 1. So I know my b value is going to be 1. And then to find out what the slope is, I have to find a nice point along the line and then count my rise over run. So I'm going to go through, that's not nice, that's not nice, this one's nice. So I'm going to put a dot here, and then I'm going to count my rise from the y-intercept to that point. So 1, 2, 3, 4. So that's my rise, and my run is 1, 2, 3. And because it's going down to the right, that means that my slope is going to be negative 4 over 3. So I know that my equation is going to be y equals negative 4 over 3x plus 1. But if I need it in standard form, then I need to bring everything to the other side so that it's equal to 0. So again, I have been bringing the y over. I'm going to, in this example, just show bringing over the x and the 1 because this was negative. But again, it doesn't actually matter what way you do it. So to get rid of these, to get it to 0, I need to do the opposite. So the opposite of this is adding 4 over 3x, and the opposite of adding 1 is subtracting 1. So again, you don't have to show it on both sides for the balance method because it starts getting really redundant. So it'll be 4 over 3x. The y stayed there, so I'm going to keep y. And the 1 brought over was negative 1. And then 0 now stays on this side because these guys cancel out, these guys cancel out, and the rest, they came over to the other side. So again, this came over to the other side, and this came over to the other side. Okay. But now it's positive, so that's good, but I still have a fraction, and I have to get rid of it. So the lowest common multiple is 3 because this is the only denominator in any of my terms. So that means I'm going to multiply this by 3, this by 3, this by 3, and technically the 0 by 3, but it's always going to be 0. So 4 times 3 divided by 3 is like 12 over 3, and 12 divided by 3 is 4. So it's like these guys cancel out. So I'm left with 4x. And you might be wondering, why am I not multiplying the x by 3 too? And that's because this whole thing is one term. So if there was a plus or minus sign in between, then yes, I would have to multiply it by the x as well. But this is one single term, so it's like 4 times 3 times x divided by 3, and that still simplifies to 4x. So that's why that works. And then 3 times y is 3y. So I'll write that. And then negative 1 times 3 is negative 3, and 0 times 3 is 0. So that's how I rearranged from slope y-intercept form to standard form. And again, if you wanted to bring the y over, so this is like another way to do it, you would have had 0 equals negative 4 over 3x minus y plus 1. But you still would have done the same thing and multiplied by 3 times 3 times 3. And then you would just have to switch your signs at the end of it. So you would have had 0 equals negative 4x minus 3y plus 3. And because that x is negative, you just switch all the signs. It's almost like multiplying everything by negative 1 actually to flip them. So it's like this times negative 1 is 0. This times negative 1 is positive 4x. This times negative 1 is positive 3y. And 3 times negative 1 is negative 3. But again, you choose which method you like. Oops, sorry. The 0 should have been last. It should have been equals 0 that way. Choose which method you prefer. But they are all the same thing, so it doesn't actually matter. And then the last example that I'm going to do with you is another figure out the equation. So here I gave you a slope of negative 1 over 4. So that's going to be my m value. And then I'll write y equals mx plus b. So I've got my m. And then passes through 2, 6. So again, this is a coordinate. So that means that that first number is x and the second number is y. So I've got all of those and I just need to solve for b to figure that out. So I'm going to plug in the numbers. My y value is 6. So I'll put that in. My m value was negative 1 over 4. My x value is 2. And I don't know what my b value is, so I'm going to leave that alone. And then I have to simplify my numbers. So a fraction times a whole number. All whole numbers have a denominator of 1. And then I do the straight across for multiplication. And I'll simplify that. So negative 1 times 2 is negative 2. And then 4 times 1 is 4. And I recopy everything else. And the only thing that changed was this multiplication part here. And negative 2 over 4, hopefully you would recognize that that can be reduced. I can divide both of these by 2 to bring it to lowest terms. So it'll be 6 is equal to negative 1 over 2, which is half, plus b. And again, the goal was to isolate for b because I want to know what my y-intercept is. So in order to do that, I have to bring this to the other side by adding half on both sides. And again, you don't have to show the balance method if you don't want to. These will cancel out. And let's bring this over to this side. So 6 plus half is equal to b. Now, we didn't go through an example that has two different denominators, but again, hopefully you know your fraction rules. And when you're adding and subtracting fractions, you needed to have common, denom, common for addition. So I got to make the 6 out of 2, and that would give me 12 over 2 plus 1 over 2 is equal to my b value. And you can see 12 over 2 is the same as 6, so these are equivalent. And then when I'm adding the fractions, I only add the numerators together. My denominator stays the same. So the b value is going to be 13 over 2. So my final equation is going to be y equals negative 1 over 4x plus 13 over 2. And then because I have to convert it to standard form, I'm going to bring everything over to the same side and then have it to be 0. So I'm going to bring over the y, or you could again bring over the negative x and the 13 over 2 so that it's positive. It doesn't matter which way you do it. So I'll say negative 1 over 4x minus y plus 13 over 2 is equal to 0. And now here you'll notice that we have two different denominators. It's 4 and 2, but the lowest common multiple is still 4, because 2 times 2 is 4 and 4 times 1 is 4. So that's how we can clear those ones. So this is times 4, this is times 4, and this is times 4. And then negative 1 times 4 divided by 4 will cancel out. So I'll get negative 1x, or just negative x. Negative y times 4 is negative 4y. And then 13 times 4 divided by 2. The 4 and the 2 cancel out, and I'd be left with 4 divided by 2, which is 2. So it's like doing 13 times 2, which is 26. But again, if you want to do 13 times 4 and then divide by 2, you can do that as well. It doesn't matter. You're going to get the same thing. So you may have written for this, I'll write it in purple, 52 divided by 2, and then it still simplifies to 26. And then all my fractions are gone, but my leading coefficient is negative, so I'm just going to flip all of the signs to make it equivalent, because again, it's like multiplying this by negative 1, this times negative 1, this times negative 1, and this one times negative 1 to get rid of that negative in front of the x. And that's my final answer. I've got my leading coefficient positive, x is first, there's no fractions, and that's how you rearrange from slope y-intercept to standard form.